In integrating thermostat control with air handling units (AHUs) and a boiler system, it is essential to understand the electrical considerations involved. We will assume the AHU to be a packaged terminal air conditioner, known as a TAC. It is important to note that this assumption may or may not be accurate in the specific scenario. Typically, a TAC is equipped with a terminal board designed to facilitate connections for a remote thermostat, even if it operates on 24 volts alternating current. In such cases, the introduction of a generic relay may not be necessary. Instead, direct connection of the thermostat to the zone output of the TOCO SR506 can be implemented, ensuring the thermostat does not interfere with the boiler's operational parameters. It is crucial to verify that the voltage rating of the thermostat aligns with the voltage of the zone output, which can be either 24 volts alternating current or 120 volts alternating current. Additionally, it is important to confirm that the thermostat contacts are appropriately rated to handle the applied voltage and current levels. Conversely, if a true TAC system is in place, akin to mini-split systems with remote controls, it is necessary to ascertain whether the remote controls operate on 24 volts alternating current or low voltage direct current. In such instances, a relay may be required to adapt the contacts to align with the TOCO zone output. To elaborate further, let's consider the situation where the thermostat voltage matches the zone output voltage of the TOCO SR506. In this scenario, direct wiring is possible. Firstly, identify the thermostat wires designated for heating control. Secondly, connect these wires directly to the corresponding zone output terminals in the TOCO SR506. Thirdly, ensure that all wiring connections are secure and properly insulated to prevent any electrical hazards. In contrast, if the voltages differ between the thermostat and the TOCO SR506 zone output, a relay becomes necessary. Here's how to implement this. Firstly, connect the thermostat wires to the coil of the relay. Secondly, wire the TOCO SR506 zone output to the appropriate contacts of the relay, ensuring they are normally open. Thirdly, when the thermostat calls for heat, it energizes the relay coil, closing the contacts and activating the corresponding zone on the TOCO SR506. Regarding the voltage and current ratings of the thermostat contacts, refer to the thermostat specifications. The contacts must be capable of handling the voltage and current supplied by the TOCO SR506. For instance, if the TOCO SR506 provides 120 volts alternating current to the zone, the thermostat contacts must be rated for at least 120 volts alternating current and a sufficient amperage to handle the load of the circulator pump or other devices connected to the zone. To select an appropriate relay, firstly, determine the coil voltage that matches the thermostat voltage, whether it's 24 volts alternating current or another voltage. Secondly, choose a relay with contacts rated for the voltage and current of the TOCO SR506 zone output. Thirdly, ensure the relay is rated for the appropriate environment, such as indoor use. Let's consider the wiring of the relay in more detail. Firstly, connect the thermostat's heating coil wire to one side of the relay coil. Secondly, connect the other side of the relay coil to the thermostat's common wire. Thirdly, wire the TOCO SR506 zone output to the normally open contacts of the relay. When the thermostat calls for heat, it energizes the relay coil, closing the contacts and completing the circuit for the TOCO SR506 zone. It's crucial to ensure that all wiring is done in accordance with electrical codes and safety standards. Also, double-check all connections to ensure there are no shorts. In regards to alternative methods, consider using a zone valve instead of a circulator pump for each zone. A zone valve opens or closes based on the thermostat's call for heat, controlling the flow of hot water to that zone. This eliminates the need for a separate circulator pump for each zone and simplifies the wiring. To elaborate on the use of zone valves, firstly, install a zone valve on the hot water supply line for each zone. Secondly, wire the zone valve to the thermostat so that when the thermostat calls for heat, it opens the zone valve. Thirdly, ensure that the boiler control system is compatible with zone valves. When considering the electrical code implications, ensure that all wiring and electrical components are installed in accordance with the National Electrical Code or NEC and any applicable local codes. Grounding is essential for safety. All electrical equipment must be properly grounded to prevent electrical shock hazards. Use appropriately sized conductors for all wiring connections considering the voltage and current requirements of the circuits. When connecting the thermostat to the Toko SR506, identify the appropriate terminals for the heating zone. These terminals are typically labeled with designations such as Zone 1, Zone 2, etc. Depending on the number of zones supported by the Toko SR506. Use a multimeter to verify the voltage present at the thermostat wires when the thermostat calls for heat. This confirms that the thermostat is sending the correct signal to activate the heating system. If the thermostat uses batteries, replace them regularly to ensure reliable operation. Low batteries can cause erratic behavior and prevent the thermostat from properly controlling the heating system. When troubleshooting issues with the heating system, start by checking the thermostat settings and wiring connections. Ensure that the thermostat is set to the correct temperature and that all wires are securely connected to the appropriate terminals. Inspect the wiring for any signs of damage, such as frayed insulation or loose connections. Repair or replace any damaged wiring to prevent electrical hazards and ensure proper operation of the heating system. If the heating system fails to respond to the thermostat, check the circuit breaker or fuse that supplies power to the system. A trip breaker or blown fuse can interrupt the power supply and prevent the heating system from functioning properly. Reset the breaker or replace the fuse as needed. If the heating system continues to malfunction, consult with a qualified HVAC technician or electrician to diagnose and repair the problem. Attempting to repair complex electrical or mechanical systems without proper training and experience can be dangerous and may void warranties. When working with electrical systems, always disconnect the power supply before making any connections or repairs. Use appropriate safety precautions, such as wearing insulated gloves and using insulated tools to prevent electrical shock. Familiarize yourself with the wiring diagrams and schematics for the thermostat, Toko SR506, and other components of the heating system. This will help you understand how the system is wired and how the different components interact with each other. Document all wiring connections and modifications made to the heating system. This will be helpful for future troubleshooting and maintenance. Keep a record of the thermostat settings, heating system performance, and any repairs or maintenance performed on the system. This information can be valuable for identifying trends and patterns and for optimizing the performance of the heating system. When selecting a thermostat, consider features such as programmable settings, remote control capabilities, and energy-saving modes. These features can help you customize the heating system to your specific needs and preferences and can help you save energy and money. Properly calibrate the thermostat to ensure accurate temperature readings. An improperly calibrated thermostat can lead to inaccurate temperature control and inefficient heating system operation. Clean the thermostat regularly to remove dust and debris that can interfere with its operation. Use a soft, dry cloth to gently wipe the thermostat housing and display screen. Avoid using harsh chemicals or abrasive cleaners, as these can damage the thermostat. When installing or maintaining the heating system, follow all manufacturer's instructions and recommendations. This will help ensure that the system is installed and operated safely and effectively. Inspect the heating system regularly for any signs of wear and tear, such as leaks, corrosion, or damaged components. Address any issues promptly to prevent further damage and ensure the continued safe and efficient operation of the system. When replacing components of the heating system, use only approved replacement parts that are compatible with the system. Using incompatible parts can damage the system and void warranties. When disposing of old thermostats, follow all applicable regulations for the proper disposal of electronic waste. Thermostats may contain hazardous materials that must be disposed of safely to protect the environment. Regularly inspect the flue or vent system for the boiler to ensure that it is clear of obstructions and properly venting exhaust gases. A blocked or improperly vented flue can lead to dangerous carbon monoxide buildup in the home. Consider installing a carbon monoxide detector in the home to provide an early warning of carbon monoxide poisoning. Test the detector regularly to ensure that it is functioning properly. If you suspect a carbon monoxide leak, evacuate the home immediately and call the fire department or other emergency services. Do not re-enter the home until it has been properly ventilated and the source of the leak has been identified and repaired. When insulating the home, pay particular attention to areas around the heating system, such as the boiler room or furnace room. Properly insulating these areas can help reduce heat loss and improve the efficiency of the heating system. Consider installing weather stripping around doors and windows to prevent drafts and further reduce heat loss. Weather stripping can help seal gaps and cracks that allow cold air to enter the home. When selecting a boiler, consider its energy efficiency rating and its compatibility with the existing heating system. A high-efficiency boiler can save you money on your energy bills and reduce your carbon footprint. Ensure that the boiler is properly sized for the heating needs of the home. An undersized boiler will not be able to adequately heat the home, while an oversized boiler will be less efficient. Consider installing a programmable thermostat to automate the heating system and optimize energy usage. A programmable thermostat allows you to set different temperatures for different times of the day, such as lower temperatures when you are away from home or asleep. Regularly inspect the expansion tank for the boiler to ensure that it is properly functioning. The expansion tank is designed to accommodate the expansion of water as it is heated and to maintain proper pressure in the heating system. If the expansion tank is not functioning properly, it can lead to pressure buildup and damage to the heating system. Consider installing a low water cut-off switch on the boiler to protect it from damage in the event of a water loss. A low water cut-off switch will automatically shut off the boiler if the water level drops too low, preventing the boiler from overheating and sustaining damage. Regularly inspect the safety relief valve on the boiler to ensure that it is functioning properly. The safety relief valve is designed to relieve pressure in the heating system if it exceeds a safe level. If the safety relief valve is not functioning properly, it can lead to dangerous pressure buildup and potentially cause the boiler to explode. Consider installing a backflow preventer on the water supply line to the boiler to prevent contaminated water from flowing back into the potable water system. A backflow preventer is a device that prevents the reverse flow of water and helps protect the public water supply. Regularly inspect the circulator pump for the boiler to ensure that it is functioning properly. The circulator pump is responsible for circulating hot water throughout the heating system. If the circulator pump is not functioning properly, it can lead to uneven heating and reduced efficiency. Consider installing a variable speed circulator pump to further optimize energy usage. A variable speed circulator pump automatically adjusts its speed based on the heating demand, reducing energy consumption and improving comfort. Regularly inspect the radiators or baseboard heaters for the heating system to ensure that they are clean and free of obstructions. Dust and debris can accumulate on the radiators or baseboard heaters, reducing their efficiency and preventing them from properly heating the room. Bleed the radiators or baseboard heaters regularly to remove any trapped air. Trapped air can prevent the radiators or baseboard heaters from properly heating the room. To bleed a radiator or baseboard heater, open the bleeder valve until water comes out. Close the bleeder valve when all of the air has been released. Consider installing a radiant floor heating system for improved comfort and energy efficiency. Radiant floor heating systems provide even heat distribution and eliminate drafts, resulting in a more comfortable and energy-efficient heating system. Radiant floor heating systems can be installed in new construction or retrofitted into existing homes. They can be powered by a variety of energy sources, including natural gas, propane, electricity, or solar energy. Radiant floor heating systems require a careful design and installation to ensure proper operation and efficiency. Consult with a qualified HVAC technician or contractor to design and install a radiant floor heating system. Consider installing a ductless mini-split heating and cooling system for improved comfort and energy efficiency. Ductless mini-split systems are a type of heat pump that provides both heating and cooling without the need for ductwork. Ductless mini-split systems are energy efficient and can be installed in homes or businesses without existing ductwork. They offer zonal control, allowing you to heat or cool individual rooms or areas as needed. Ductless mini-split systems require professional installation to ensure proper operation and efficiency. Consider installing a geothermal heating and cooling system for the most energy efficient and environmentally friendly option. Geothermal heating and cooling systems use the Earth's natural heat to provide heating and cooling for homes and businesses. Geothermal systems are very energy efficient and can significantly reduce your energy bills. They are also environmentally friendly, as they do not produce any greenhouse gas emissions. Geothermal systems require significant upfront investment, but they can provide long-term cost savings and environmental benefits. Geothermal systems require professional design and installation to ensure proper operation and efficiency. By carefully considering all of these factors, the heating system to meet your specific needs and preferences and ensure the safe, efficient, and reliable operation.